Welcome to the Fuel Pulse Show podcast, where we talk about all things fuel for all kinds of people. I'm your host, Erik Bjornstad. Today, I'll be your host and your guide through the ever-changing world of fuel. So here at the podcast, we talk about all the things related to all of the different kinds of fuel that you use both at work and at home. Plus, in addition to that, we also talk about all the things that use that fuel, both at work and at home, which means the Fuel Pulse Show podcast is really for everyone. And so what are we going to talk about today? Well, we are currently progressing steadily through the winter season. And you may recall in our previous episode of the podcast, we talked about the winter forecast for all the different areas of the country. And I think the forecasters have generally hit the right mark. Currently, there are a bunch of winter storms marching across the country, which means hopefully if you use stored diesel fuel at your business or for your job, hopefully you have been preparing that fuel to weather these storms. But winter will eventually be over and the weather is going to warm up. And so concerns are going to transition away from keeping diesel fuel from gelling in cold temperatures to a concern about heading off the water problems and the microbe problems that tend to explode when that weather gets warmer. Now, what is the common thread running through all these seasons? I guess there are several answers you could give to that, but what I'm thinking is the common thread is that every season of the year presents situations and phenomenon that result in generators and backup systems shutting down for certain reasons. And so today, we don't want to concentrate so much on the role that the fuel might be playing in that situation, but we want to take a little bit different approach. We want to propose something like the following. If you have a generator system, like an emergency backup generator system or something else, if you have one of those that is experiencing sudden problems, and by problems, we're going to be referring to a no-run situation where it won't stay running or a no-start situation where it just won't start. If you have a generator system that is experiencing one of those kinds of problems, the easiest thing to do is blame the fuel for being the cause of the problem. But we want to propose that the fuel is not always to blame. It often does get the blame when it's not the real cause of the issue. And that, unfortunately, can be a problem because just as with medicine, a misdiagnosis in that kind of situation, A, it doesn't fix the problem, and then B, it ends up costing you additional time and money that you can't really afford to lose. So on this episode of the Fuel Pulse Show podcast, we're going to talk about some of the practical steps and things that you can look at when you're faced with this kind of situation. Things you can do that can help you get at the real cause of the issue with your generator system. And so with that, let's jump in. And let's start by describing a scenario where if this hasn't specifically happened to you, you probably know somebody it has happened to. So you have a backup generator system that runs on stored diesel fuel, and your generator system shuts down or it won't run. So what do? Well, you call in the generator service company and they send a technician over to diagnose the problem. And the technician looks things over and issues a relatively simple diagnosis. Says the system will run because the fuel is bad. The fuel's bad. Now, this is something that we have run into at least a few times over the past several years. We've seen businesses that encounter situations where their generators shut down or they won't run. And in response, we've seen numerous generator service technicians assess those situations and then claim that that no start or no run condition is due to bad fuel condition. And yet, when samples of the fuel in question might be submitted to a third-party lab for testing, the test results come back showing that the fuel is in fact in pretty good condition, good enough even to meet all of the ASTM D975 specifications for inspect diesel fuel. And so this presents somewhat of a contradiction. How did that technician know to blame the fuel? For what reason are they blaming the fuel if the fuel test came back so clean? Tests show there's really no reason to expect that the fuel isn't going to work like it normally does. This seems to be a little bit of a puzzle. Now, for the business in question, a no start or no run condition for their generators is a serious matter. It means that system is not working when they really need it to. But the answer as to why that is, it's likely out there. We just have to ask the right questions. Now, for the business, a no start or a no run condition for the generator system is a serious matter. It means that their generator system is not working when they really need it to. And the answer as to why is likely out there. It can be found. We just have to know the right questions to ask. We have to know the right approach to take, if you will. And it's important to take the right approach to finding out the true answer to that condition instead of relying on assumptions that could well prove to be wrong. See, most of the generator service technicians who conclude that the condition's due to a fuel problem, they actually don't know that much about fuel, but they'll blame the fuel anyway because it's the easiest thing to do. Make something else the culprit other than what they do, for example. It makes sense. That is the easiest thing to do, blame the fuel. But you have to consider that in many cases, the fuel won't actually be the real culprit. Now, it's important to get the right answer here because things can get expensive chasing a diagnosis that isn't actually the right answer. Having a correct diagnosis here means that you'll be able to actually fix the problem. And just as importantly, it enables you to avoid those expensive tail-chasing scenarios that can end up costing you thousands while leaving you still with that ongoing problem that hasn't been resolved that ends up many times costing you even more. Now, all this is especially true if that incorrect diagnosis leads you to have to replace certain parts on your system or keep replacing parts on your system that turn out not to even be the real problem. Now, that particular thing can happen either because the technician incorrectly blames the faulty parts for your system shutdown, or they incorrectly put the blame on the fuel that interacts with those parts. So maybe a service technician surveys your shutdown problem, incorrectly tells you that you need to replace the injectors or that you need to replace the fuel injection pump to get your system up and running. Well, replacing injectors is going to cost you at least $1,000. Replacing fuel injection pumps can push that cost to $5,000 or more. Or maybe the technician just tells you the fuel's bad and then advises you to dump that fuel. Now, for the average person, that doesn't seem so bad. But when you really look at the details of what goes into that kind of scenario can get really expensive really fast. Because these days, it's not as simple as just going somewhere with a tank of fuel and then, making that fuel disappear, right? No, you have to have a licensed company come out to your location. They're going to charge you a basic disposal fee that doesn't go by gallons, it goes by the weight of the fuel. And it could be anywhere from, 80 cents to $3 per pound, which comes out for number 2 diesel, that comes out to between $5 and $20 per gallon to dispose of that fuel. Then on top of that, you've got extra fees. You've got labor, you've got service charges, you've got hazardous waste transportation fees, which can typically be a couple $100s or more, depending on the state. There's also environmental and additional regulatory fees. And then, after all that, you still have to pay to replace that old fuel with new fuel on top of it. So, let's run some numbers. Let's say that a generator service technician comes out, you have a 500-gallon tank, and they say, those 500 gallons of fuel, that's bad fuel. That's causing your problem. You need to dispose of that. So if we pick a median disposal cost of, let's say, $2 per pound, that means you're going to start with a total bill of $6,500 to $8,500 to dispose of that 500 gallons of fuel. Then another $300 in various fees. Then another $1,700 on top of that to replace it with the new fuel. in case you're mathematically challenged in all this with those numbers, you're pushing $10,000 in total to resolve that problem. So in either case, whether you're replacing system parts that supposedly have gone bad, or you're replacing fuel that supposedly has gone bad, both of those are expensive fixes to get your system up and running. You want to be sure, if you're going to spend that kind of money, you want to be sure that they are indeed the right answer. But question to consider is, what if those solutions aren't actually linked to the real cause of the problem? Because there's so much at stake here financially, it's worth your while to dig a little deeper and maybe come up with the right solution so that you don't end up dropping substantial amounts of money on fixes that don't fix the problem. So if you want to find out the right answer to what's causing your operational problem, you are going to have to look a little deeper. And so what we're going to do is we are going to talk about some things that you can do. So let's look at areas of the fuel system to look at. So to go back to the beginning and kind of reset this scenario, we're looking at a situation where we have a no run or a no start condition for our generator system that is running on stored fuel. Service technician comes out, declares bad fuel to be the culprit, or they declare that you've got a faulty part, a faulty injector, fuel pump's gone bad, those need to be replaced. That's our starting point in this. But as we've introduced, many times the fuel is bad isn't actually the right answer to the problem. So you've got that, and then you've also got the very real possibility that faulty parts aren't actually the real problem you have to deal with. So there are elements of the fuel system that we need to look at to make sure that they aren't the real cause of the problem. And so that is what we're going to do here. We're going to introduce a series of steps to have you walk through that many times may end up pointing you to a fix for your problem that ends up being much simpler than either of those other two more expensive things. Let's start with number one, checking the fuel filters. That's diagnostic step number one. If the engine shuts down or the generator won't come up to RPM, won't come up to or maintain load, it's a good rule of thumb that simply changing the fuel filter or filters can oftentimes remedy the problem. So first thing you want to do is you want to start by changing your primary and your secondary fuel filters. Then, if changing those filters solves the running problem, great. You've suddenly fixed something for a relative drop in the bucket when it comes to money. However, if it doesn't fix it, then you're going to move on to step two. That's step number one, change your fuel filters. Once you've done that, there's something that you need to do with the old filters that's going to relate to something else that we're going to talk about a little later. Take the old filters, take a hacksaw, cut those filters open and inspect the paper medium that's inside. And what you're looking for is you're looking to see if there's anything that resembles any kind of black or neutral colored slimy growth that happens to have gotten trapped and caught on that filter. And the reason you're looking for this is because if you find that, it's going to actually tell you two important things. It's going to tell you that you most likely had some kind of microbial contamination situation growing in your system. And you also most likely have water in your system. The water, the second one, is almost always linked to the first one. Because in most cases, doesn't matter what kind of system you're looking at, in most cases, if you have water present, you will also have microbial growth present. If you find that, your tank's going to need to be treated for both issues over and above you having gotten that generator system running again. But the bright side's pretty clear. If changing the filters resolves your problem, then you've solved the problem and avoided a 4 or 5 figure solution that actually wasn't a solution, and you've solved your problem for the minute cost of a couple of filters. Plus, you've also possibly identified a future micro problem that you can now take steps to solve and prevent future problems at the same time. So that's diagnostic step number one, change your fuel filters. Diagnostic step number two is check the fuel line. So If changing the filters didn't solve your problem, you don't have to worry because there are other things that you can look at. That's really just the first thing. And you don't really have to worry about this because proper diagnostic procedures, when problems in systems that have multiple parts like yours, they often involve moving through multiple steps to try and locate the cause of the problem or to cross a particular possibility off the list. As we go through these steps, we go through some of these alternative things to look at. What we're going to say is after each one, what you're going to do is you're going to do it, and then you're going to see if your system will run. If your system runs, you found the solution. You don't need to continue anymore. Or if it doesn't run, you then move on to the next possible cause. Okay, so after you check the fuel filters, you're going to start with looking at the fuel line that's going into the tank. What you're going to do is you're going to take that fuel line and you're going to try and blow air back through the line to make sure that there's no obstruction in the line. Obviously, if you have an obstructed fuel line, that means you have obstructed fuel flow. And it's pretty hard for a generator system to work if the fuel flow is blocked, right? Now, there is one caveat here, though. If the fuel line, and this is relative to the design of your particular system, if your fuel line has what they call a foot valve, then blowing air into it like we suggested actually is not going to work because what that foot valve is going to do, that foot valve is simply going to close when you try to do that and no air is going to pass through it. So that's the caveat with that. So that's diagnostic step number 2. Make sure that the fuel line's clear. Now, diagnostic step number 3 is going to involve looking at one or more of those valves that we talked about. So after making sure that the fuel line's clear, extracting the fuel line from the tank for inspection and cleaning that fuel line is going to be the next step after that. And while you're doing that, you're going to take a closer look at that foot valve that we talked about. Now, not all fuel systems in generators have one of those foot valves. If your tank doesn't have one of those, instead what you typically will find is you'll find a different kind of valve, a check valve located in the same fuel line. Check valves are typically found between the tank and either the lift pump or the primary filter. And the purpose of this check valve is they function to prevent fuel drainage going back that can contribute to causing slow starts when you have extended engine cranking, right? So diagnostic step number 3, after you've changed your fuel filters and after you've made sure that that fuel line is clear, diagnostic step number 3 is going to be remove the foot valve or the check valve and clean it to make sure that it is free to work properly. Then reinstall the valves and check to see if your system now runs. Hopefully it does. If it doesn't, then you go on to diagnostic step number 4. And diagnostic step number 4 concerns the fact that your fuel system might have a third fuel filter in the line from the fuel tank. Then that fuel filter tends to resemble an automotive type inline fuel filter. Not all systems have this third kind of filter, but you should definitely check if it does. And if your system does, you locate it and you try replacing that as well and see if your generator now runs. So you've gone through 4 relatively simple steps, and it is entirely possible that any of those 4 could actually be the thing that resolves your generator no start, no run situation. Any of those 4 simple steps could turn out to be the real cause of your problem. And this kind of troubleshooting sequence that we've been running through, it's worth working through because if the problem really is any of those, you're going to have saved literally thousands of dollars with one simple fix. If you're faced with the possibility of paying thousands of dollars to either dump fuel or replace expensive parts like the injector pump, if that's what you're being faced with, it's really important for you not to do that until you've worked through these initial procedures. So that's the 4 simple steps. Now, to this point in the process, you've done at least those 4 things, right? Now we want to touch on something that's related to it, but is also something that's important besides that. Earlier, you remember one thing we alluded to was the value of paying attention when you did step number 1 and you change the primary and secondary filters, we say cut them open and look to see if there's evidence of microbial contamination in there. And so that's the value of paying attention to whether either of those filters clear you into the possibility of microbial contamination growing in your system. See, with today's ULSD fuels being so susceptible to fostering microbial growth, contamination is becoming a problem that's more and more widespread across the landscape. So at this point in the diagnostic process you're working through on your system, you really do want to make sure you know whether microbial contamination might possibly be a contributing factor to your operational problem. Because if it is, it can be remedied for a whole lot less than having to dump the fuel or replace expensive parts. But you do have to look closer at some areas in order to figure that out. Earlier, when you cut those fuel filters open, if you saw those telltale signs, well, that's one definitive clue, if you will, that you've got a problem going on there. Seeing or feeling black or clear slimy stuff in the fuel filters on that filter medium is almost a dead giveaway that that's present. Now, beyond that, there's another thing that you'll want to do is examine your water separator filter. Water separator filters are a perfect environment for microbial contamination to grow and multiply, and then they get dispersed out to wherever else the fuel goes. And why shouldn't we expect them to be that way? Because, it's a water separator filter. Microbes can grow anywhere water's present, anywhere where there's an available supply of moisture, which is something that happens to be true with water separator filters, right? And yet often for some reason, we don't ever consider that the water separator filter might be a source of this problem. Now, if you're checking your water separator filter, what are you going to be looking for? Well, there's like 5 basic kinds of things that you would be looking for. Okay, thing number 1 is if you see the same kind of black or clear slimy residue that you saw in the fuel filters, that's a dead giveaway that your water separator filter's fostering microbial growth. Thing number 2 is smell it. If there's a distinctly kind of sour or rotten smell, that's probably coming from sulfur compounds that are being produced by some sulfate-reducing bacteria. That can be a sign that you've got a microbial problem. Number 3 is if you see on the filter paper or the filter medium in that water separator filter, if you see this thing they call leopard spotting, you see spots. Those spots are colonies of microbes that are grouped together and have gotten large enough to be able to be detected with the naked eye. Now, a microbiologist would say that you need at least 1 billion microbes together to form a colony spot that is just large enough to be able to be detected by the naked eye. So that's the kind of scale we're talking about here if you happen to see leopard spotting on your filter medium in your water separator filter. Thing number 4, if you see clumps or particles of organic matter in the separated water or the fuel that's in the filter, that is a sign of microbial contamination. And then also number 5, if you see cloudy or milky liquid in the separator, what that means is that you've got microbial contamination that has led to the development of a fuel water emulsification. And that fuel water emulsification could actually be something that is specifically contributing to a no-start or no-run situation for your generator. So you inspect the water separator filter. If any of these signs that you see lead you to suspect you've got microbial contamination, then the best practice is you should have it confirmed through testing. Now, there's different ways that you can test for microbes. The best one out there is called ATP biofiltration, and there's also culture tests, a number of different kinds. Some are better than others. A test methodology like ATP biofiltration will confirm if you have such contamination or not, and it will actually give you a specific idea of how much you've got. This ATP test, they're relatively easy to perform, especially if you utilize, let's say, a testing kit. There's companies like Bell Performance that produce testing kits where they send you a box and it has everything inside for you to draw a sample, put the sample in a sample bottle, sample container, package it up, seal it up. It has prepaid shipping. It sends it to a lab. They do the ATP microbial testing, and then they tell you what your results are. Pretty easy, pretty fast. So you have it tested. If the results confirm that you do have microbial contamination in your system, now it's important to treat the tank with a biocide, which is a chemistry that's specifically designed for and approved legally to be used for killing microbes in places like fuel storage tanks and fuel distribution systems. So you want to treat your tank with the biocide. You want to replace your filters because biocide will kill the microbes, but the microbes then have to be filtered out, which means you're going to probably have to change your filters. So you're going to have to do those things. But if you do those things, you will resolve a microbial contamination problem. And many times, resolving a contamination like that can actually resolve a no-start or a no-run situation. But even if it turns out that your no-run situation's not directly caused by your microbial contamination problem, maybe it's caused by something else, like the fact you had to replace a fuel filter. Even if that turns out to be the solution, if there was evidence that you found that you had a microbial contamination issue, that's something you absolutely need to resolve regardless, whenever you find it. Because if you don't, it is only going to spread, and that is almost a rock-solid guarantee. If you have evidence of microbial contamination, it's never a question of if it's going to lead to a future problem. It is always a question of when is that going to happen. And so you don't want that to happen, so you do need to get it cleared up. Okay, and so with that, we're going to stop things at this point. And next time in part 2 of our discussion, we're going to talk about some of the things that you can do if what you've done up to this point don't seem to have solved your system performance issues. So you've run through the 4 diagnostic steps. You changed those filters, you made sure the line's cleaned, you checked those valves, you cleaned them out, made sure that they are working properly. If you have that 3rd filter, you've changed that, you've done all that. Each time you started the system up, still doesn't work, still doesn't maintain load. So you're like, what do I do next? Well, that's what we're going to talk about in part 2. We're going to talk about things you can do if what you've done up to this point hasn't resolved your issue. That means that we're going to talk about the ways that fuel can and cannot be responsible for some of these no-run, no-start situations. And then we're going to talk about some of the things, the specific things that you can do to narrow the diagnosis down so that if it does happen to be the fuel, you can know more specifically what you should do about that. And so that's going to do it for today's episode of the Fuel Pulse Show podcast. Thanks for joining us today. If you like what you heard, we're going to have links to things that we talked about in the show notes. As always, if you have not subscribed to the Fuel Pulse Show podcast, you are more than welcome to by subscribing at your podcast purveyor of choice, whether that's iTunes, whether that's Amazon Podcasts, Google Podcasts, Stitcher, Spotify, wherever you get your podcasts served up to you. Subscribe if you haven't already. Leave a review. That's helpful as well because the algorithms really like podcasts that get reviews. Really helps people find us. So, till next time, I am Erik Bjornstad, your guide through the ever-changing world of fuel, and I'll see you next time for the next episode of the Fuel Pulse Show podcast.